let's see what we got here. This is another one where they're giving us all the information and they want from us the equation that goes with that information. All right. So x equals 2 is the only vertical asymptote. So there's a vertical asymptote right here. The x-intercepts, is 1, 3, and 4. Okay. 1, 3, and 4. Interesting. The y-intercept is positive. Okay. For large values of x, this thing kind of approximates to be approximated by an x squared. In other words, it's approximately x squared. So at the end, it's going to go up like that and up like that, because that's what x squared looks like. Okay, here's what I would say. This thing crosses somewhere at positive range, and it drops down. The reason why I think it drops down is because well, here's what my thoughts are. I think that on the right-hand side of this parabola, this thing kind of looks like, or on the right-hand side of this vertical asymptote, this thing kind of looks like a parabola. It goes up because it crosses at these 2 points here. So I'm thinking that this jump across this vertical asymptote is an odd jump, because it would kind of tell me if it were an even jump. Well, to be honest with you, I wouldn't really be able to tell that information. So this is what I'm thinking is, as this thing goes up to infinity, this thing's going to start from down to infinity. All right, what would the equation like that look? Okay, so I have a denominator, and in that denominator I'm going to put x minus 2. And I get that information from here, because this tells me my vertical asymptote is when x cannot equal to 2, or that's why it's the vertical asymptote is at x equals to 2. The numerator is given by basically this information. You basically say x minus 1, x minus 3, and x minus 4. The y-intercept is positive. Well, we can check that. If I plug in x equals 0 into here, this would be negative 1, negative 3, and negative 4 over negative 2. Alright, let's see, I'm multiplying all of this. So this times this is a positive number, and this divided by that is a positive number, and that's going to be a positive number, so we're good. We don't need to slap on a negative out in front. And then this thing is approximated by x squared. Well, if I multiply out the numerator, I'll have x cubed, and if the leading term in the denominator is just x, which leads to x squared. I'll tell you what, why don't I try graphing this, x minus 1 minus 3 minus 4 divided by minus 2, okay. Why don't I try graphing this and see what I get. Minus 3, x minus 4, divided by minus 2. Hey, that's kind of what I got. That's exactly what I got, actually. See, it kind of said it would go like that. That's exactly what it looks like. Cool. You know what I kind of want to try is graphing x squared and see what that thing is, because they said it's approximated by that, and we'll see what happens. X squared. It looks to me like it's almost a shifted parabola as I expand this thing out. Why is this not responding? Come on, Desmos. Stop crying. Stop with me on. 2x, no, not 2x. X squared. Yeah, okay. Alright, so as I get far enough away, then my red graph kind of looks like my orange graph. It's just shifted a little bit. But it still could be approximated by that. Things are not responding. I'm just going to press stop and see what happens.